Unit 11 Geometry Exam Review. Number 1, a snowmobile in open country must go 31 kilometers south of 15 kilometers east to get home. Now this is one where you're going to actually draw this. The best idea is to draw it and you decide which direction. I always go in order. So it's going to go 31 south and then 15 east. So I went 31 south and I label that. And then 15 east and I label that and I connect to my end point and make a right triangle. Which direction should it head? Because we're touching the south, you went east of south. So we know that we are going to say east of south. In addition to that, you need an angle measure, and that angle measure is what I just marked as theta there in this right triangle. Since I know the opposite and the adjacent, we're going to figure that out by doing the tangent of theta equals 15 over 31. And then on my calculator, making sure I'm in degree mode, which I am, I'm going to simply get theta alone by doing the inverse tangent of 15 divided by 31, which is about 25.8 degrees. So you'd say that this is heading 25.8 degrees east of south. How far will it travel? That's this distance x. We're going to use the Pythagorean theorem. You can say 15 squared plus 31 squared equals x squared. So essentially what I'm going to do is 15 squared plus 31 squared. I'm going to get that answer and I'm going to take the square root of it. So it went about 34.4 miles. Number 2, I believe, is pretty much the same question, only now we're headed 132 kilometers east. So we're going east first, and then we're headed south. So labeling again, 132 east, 271 south. Create your right triangle once again. We want theta. First of all, we're heading south of east. Whatever side of the coordinate plane you are touching, that's what comes last. So we're south of east. And now, same process here. I'm going to do an inverse tan of my opposite, 271, divided by my adjacent, which is 132. We get 64 degrees south of east. How far will it travel? Once again, I'm going to call this x. We've got 132 squared plus 271 squared equals x squared. I'll go ahead and do the square root ahead of time here. Square root of 132 squared plus 271 squared, about 301.4 kilometers in this case. So there are your answers for 1 and 2. An airplane is headed to an airport, another one of these. Only now we are headed south first, and then west. Make your triangle. We went 865 south, 729 west. By now you can see this, hopefully. There's your right angles. What direction? We were touching south, so this is west of south. To find that angle measure, opposite over adjacent, I'm going to do inverse tan of 729 divided by 865. You get 40 degrees. So we are 40 degrees west of south. And then how far? Again, x. Got 729 squared plus 865 squared equals x squared. I know I'm going to square root, so I'm going to take care of that in the first place. 729 squared plus 865 squared. And it's headed about 1131 miles. Same process for each of the first three, not too bad. For these, remember, we're finding area. The area formula from Unit 11 is 1/2 times A times B times the sine of the angle between them that we call C. So if you want to draw these triangles, not a big deal. I call this side AB, this side will be BC. Got my triangle, obviously not drawn to scale, 16, 12. Angle B is 60 degrees between them. I look at this and say, hey, the area equals 1/2 times 16 times 12 times the sine of 60 degrees. And you get the area to be about 83. So I'm going to say units squared. That's how you go about that. Next one, same situation. We can draw it. CD, DE. This is 13. This is 27. Angle D we know is 41 degrees. You can easily see it's an, remember these triangles have to go SAS, SAS as they do. 0.5 times 13 times 27 times the sine of 41, and you get 115. So that is your area for number 5. Moving on to number 6. Of the numbered angles, of the numbered angles, which has the least tangent? Remember, tangent is opposite over adjacent. Okay, so each of these angles, 1, 2, and 3, they all have the same opposite. For angle 1, it would be this just small triangle right here. Its opposite would be this. Angle 2 would be this whole triangle that I'm kind of ghost tracing right here. The opposite would be right here. Same opposite. And same thing for 3. So if they all have the same opposite, let's say that the length of this is 1, the length of this is 2, and the length of the bottom one is 3. And let's say this, for example, the length of this tangent is 2, then your opposite over your adjacent for angle 1 is going to be 2 over 1, which is 2. For angle 2, it's going to be 2 over 2, which is 1. For angle 3, it's going to be 2 over 3, which is less than 1. So which one has the least tangent? You'd say angle 3, because it has the same opposite, but the longest adjacent. For number 7 of the numbers, which has the least sine, once again, sine is opposite over hypotenuse. And for the same exact reason, they have the same opposite, but the opposite, or the hypotenuses are getting longer. The one that has the least sine would again be angle 3, because it's going to have this length, whatever it may be, divided by a bigger number than the other two. So it would have the least sine. The numbers angle which has the greatest cosine. Now, cosine is a little bit trickier. Now you have the adjacent over the hypotenuse, the adjacent over the hypotenuse, and the adjacent over the hypotenuse. So in this case, you would have to get out a ruler and figure that out. But I would say, I mean, if you look at it, the adjacent over the hypotenuse in each one of these, this adjacent is the closest in length to the hypotenuse. So therefore, I'd say the greatest cosine would again be angle 3. Exact value of the sine of 30, this is kind of knowing your unit circle. In fact, for all of these, well, I guess I'll go with it from a special right triangle standpoint. And I'll put those up right now. Here's your special right triangles, which you should know moving into your exam. X, 2x, and x squared root of 3. And then since there's a 45 right there, I'll put up the isosceles right triangle as well, where you have a 45-degree angle, a 45-degree angle, a 90. These ones are x, x, and x squared root of 2. So if I want the sine of 30, from 30 degrees, sine is opposite over hypotenuse. X over 2x, the x's cancel, leaving you with an exact value of 1/2. You could obviously also know your unit circle for this. Cosine of 45 degrees, I use this 45 degrees adjacent over hypotenuse. So we've got x over x squared root of 2. The x's cancel, leaving me with 1 over the square root of 2, but that's not your answer because you have to get rid of a square root on the bottom. It's going to leave you with the square root of 2 over 2. Once again, know your unit circle. That's another way of doing that. Tan of 60 degrees, that's opposite over adjacent. So for this one, we've got x squared root of 3 over x. The x's cancel, leaving you with square root of 3. And the exact value of tan of 30, opposite over adjacent, leaves me with x over the x squared root of 3. Last thing, only flipped. Cancel the x's, you have 1 over the square root of 3. Can't give your answer like that. You have to multiply by the square root of 3 over the square root of 3, leaving you with the square root of 3 over 3. And those are your exact value answers. Find the length. This is one where you're going to need to find a conversion factor or a k value. I'm going to go ahead and label everything. Vy is 4. Wx, this whole length here, is 20.3. Vx is 7. And xy is 3. Notice how for this side, the top side, I know both the small length, which is 7, and the large length, which is 20.3. That gives me either a k value, which is a conversion factor that you multiply or divide by, or if you like proportions, like I do, it's going to give you one side of your proportion. So if I want WZ, I'm going to say, okay, I know the small side of my top half, 7, over the large side. That has to be equal to the small side of this over the large side. So 4 over WZ. And just like last unit now, we cross multiply. I've got 4 times 20.3, and then I'm going to divide that by 7, which gives me 11.6 to be the length of WZ. For XZ, same thing. I know the small version, so I'm going to say 7 over 20.3 equals 3 over XZ. And for the same reason, here we go, 20.3 times 3, again, cross multiplying, divided by 7 gives me a length of 8.7, and that is the length of XZ. Moving right along. Number 14, I'm going to go ahead and label these. MN is 13, PO is 8, OQ is 9. Right there, I know the small and the large version of that. MP is 15. If I want to find PQ, that's the small version of 15. So I'm going to go again. I've got 9 over 13, equals PQ over 15. Just setting up a proportion. 9 times 15 divided by 13 gives me 10 point, I'll call it 10.4. It says to the nearest tenth. ON, now this one's a little bit trickier, but not too much. I've got 9 over 13 again, and then PO is my small version over here. I'm going to say that's 8, and then my large version would be PN, and I know that's not what I'm looking for. I'm looking for ON, but once I find PN, I can just subtract 8. So let me go ahead and do that. So I've got 13 times 8 divided by 9. So the distance for PN is 11.6, but then I don't want PN. I just want ON. So I would subtract 8, and that means ON, just that length there, would be 3.6. And that is your distance, your answer there for number 14. For number 15, isosceles right triangle. Okay, so you're going to label an isosceles right triangle, which I already did earlier. X squared root of 2. This is your roadmap. Got to know it. How do we label it? Well, it says C is 90, and then these A and B don't matter. But it tells us AB is 12, so I'm going to go ahead and set this equal to 12. Now, if I can get X all alone, that'll tell me the length of both AC and BC, which is what I want. So I'm going to go ahead and I'm going to say X squared root of 2 equals 12. Divide by the square root of 2 to get X all alone. And X equals 12 divided by the square root of 2. Can't leave it like that. You got to rationalize the denominator, which would give us 12 square root of 2 over 2. 12 divided by 2 is 6. So X equals 6 square root of 2, 6 square root of 2. And that's the length of both of these sides, because they must equal X. Didn't follow that, I'll go around again. This is pretty much the exact same question for number 16. X square root of 2. Once again, this is C, this is AB, so it tells me X squared root of 2 equals 9. I want to get X all alone. That'll find the length of these, so I divide by the square root of 2. And I get X equals 9 divided by the square root of 2. Can't leave the square root of 2 on the bottom, so I have to multiply top and bottom by it. I get 9 square root of 2 over 2. I can't divide 9 divided by 2 like I could with 12. So the answer here is just 9 square root of 2 over 2. And BC being the same length is the same answer. Now I've got a 30, 60, 90 triangle. Remember, 30, 60, 90 across from the 30 is X, across from the 90 is 2X, and across from the 60 is X square root of 3. How do we label it? Tells me F is this, tells me D is our 30, so E